their surrounding environment while in transit. Robert Britzler, Program Manager, Sea Platforms and Weapons. During a recent swarm boat demonstration in the lower Chesapeake Bay, ONR developed boats achieved a key milestone in the area of autonomous control. Unlike purely remote-controlled boats, these boats are able to perceive their environment and plan their routes without human intervention. The role of the human is supervisory control, Britzler said. A human at a control station, using a low-bandwidth connection, can perform command and control functions without needing to actually drive the vessels. The demonstration used 4 USVs, working in tandem to perform a range of potential maritime combat operations. All 4 of the boats were able to see and sense a common picture for route planning, hazard avoidance and collision prevention. Developers said, "We are using a first-of-its-kind sophisticated perception engine which senses the presence of other vessels using a combination of sensors, radar, cameras and processing algorithms," Britzler explained. The ONR demonstration used 7 to 11 meter boats already in the Navy inventory as manned boats, and configured them with an autonomy kit enabling a range of unmanned mission possibilities. The kits, called Control Architecture for Robotic Agent Command and Sensing, or CARACAS, are engineered to provide USVs with an ability to handle dynamic operational situations. This can include the execution of search patterns, harbor defenses, surveillance or even swarm boat attacks. Other possibilities among a wide range of uses include using autonomous USVs for supply and weapons transport, counterman operations, electronic warfare and amphibious operations. The USVs are programmed with sensors linked to an established database of known threats such as enemy boats. They are also linked to one another with an ability to detect, track and trail unknown boats, Britzler said. ONR is working closely with the Pentagon's once-secret Strategic Capabilities Office, or SCO, in an effort to fast-track this technology into operational service. The Strategic Capabilities Office is a special DoD-level effort to harness, leverage and integrate near-term emerging technology for faster delivery to combatant commanders at war. Much of this involves merging new platforms, weapons and technologies with existing systems in a manner that both improves capability while circumventing a lengthy and often bureaucratic formal acquisition process. Dr. William Roper, SCO Director, told a small group of reporters. A key advantage of using remotely controlled drone ships is that, quite naturally, they can save sailors and marines from being exposed to enemy fire during an attack operation. In fact, Roper maintained that USV autonomy brings the potential of substantially advancing amphibious warfare tactics. This can greatly help expeditionary logistics for a ship that is standing off from the shore. Instead of having to use an amphib manned by a lot of people, you have an unmanned supply boat, Roper explained. Fast-moving USVs could indeed lower risk and increase efficiency for a large number of missions, to include intelligence, surveillance and reconnaissance, ISR, counterman operations, search and rescue, electronic warfare, supply and weapons transport and amphibious assaults. Higher-tech enemy sensors and longer-range surface and land-fired weapons have drastically increased the vulnerability of approaching amphibious assault operations, making them more susceptible to enemy fire. As a result, the Navy and Marines have been evolving amphibious tactics to include more disaggregated approaches designed to spread out an approaching force, making it more difficult for enemy weapons to attack an advancing assault. For example, the Iwo Jima attack in the Pacific during WEI, an historic amphibious assault, involved a group of Marines approaching enemy shores in close proximity to one another. Weapons, Marines, equipment and attacking infantry all came ashore in rapid succession. Modern threats are changing amphibious tactics to succeed against higher-tech, more lethal enemy weapons. Instead of having to land as a single unit, they can now break out. There is safety in numbers and they can redistribute, Roper explained. When it comes to offensive surface operations, unmanned boats could form a swarming of small attack craft designed to overwhelm and destroy enemy ships with gunfire, explosives or even small missiles. Roper explained that this strategic and tactical trajectory is greatly enhanced by the possible use of USVs. The Navy's current inventory includes ship-to-shore amphibious craft called landing craft air cushions, LCACs, and landing craft utility vehicles, LCUs, these platforms, now being upgraded by newer transport boats able to move faster and carry more payload, such as Abrams tanks, are manned and therefore involve the use of a crew. LCACs require a crew of 13, and LCACs use a crew of 5. New high-tech LCAC replacements, called ship-to-shore connectors, are already being developed and delivered to the Navy by Textron. The Navy and ONR are already immersed in the development of a variety of USVs, including a mine-detecting unmanned influence sweep system, or UIS, for the littoral combat ship. The UIS is carried by a Textron-developed Common Unmanned Surface Vehicle, or CUSV. The CUSV, in development since before 2009, can travel for more than 20 hours carrying up to 4,000 pounds at speeds of up to 20 knots, Textron information states. Also, it is engineered to withstand waves up to 20 feet. The UIS is engineered to find and detonate undersea mines in order to save sailors and manned vessels from a potentially deadly explosion. The Navy's UISS will be towed behind the unmanned vehicle and will emit sounds and magnetic signatures that mimic a ship, setting off nearby mines that listen for passing ships, according to a report from the U.S. Naval Institute. The Navy is also advancing its recently christened Defense Advanced Research Project Agency, or DARPA, inspired submarine hunting unmanned ship called Sea Hunter. The ship is built to travel up to 10,000 miles while using sonar and other sensors to locate enemy submarines. A high-frequency sonar will send acoustic pings into the ocean before analyzing the return signal to determine the shape, size, speed and characteristics of any undersea enemy activity. The 135-ton ship is engineered to withstand rough seas up to sea state 5, or waves up to 6.5 feet. The effort began in 2010 as an anti-submarine ship called ASW Continuous Trail Unmanned Vessel, or ACTUV. The Sea Hunter can be controlled by a human teleoperator able to maneuver the ship with a joystick. Also, it is possible the Sea Hunter could be armed with lethal weapons in the future, a scenario which current Pentagon doctrine says much hinge upon a human decision-maker in the role of command and control. The Sea Hunter can be controlled by a human teleoperator able to maneuver the ship with a joystick. However, the progress of the platform's technology, and the rapid advancements of algorithms enabling greater levels of autonomy, have inspired the Navy to